Have you ever wondered why deserts bloom in some places, while lush rainforests thrive in others, even at similar latitudes? The answer often lies hidden in the invisible currents that constantly sweep across our planet, shaping its destiny. Prevailing winds are a primary driver of Earth's climate zones, significantly influencing temperature, precipitation, and moisture distribution across the globe. These consistent wind patterns redistribute heat and moisture from the equator towards the poles and vice versa, creating the distinct climate regions we observe. The fundamental mechanism involves the unequal heating of Earth's surface and the Coriolis effect. The sun warms the equator more intensely, causing warm, moist air to rise. As this air moves towards the poles, it cools and descends. The Coriolis effect, caused by Earth's rotation, deflects these moving air masses, creating global circulation cells like the Hadley, Farrell, and polar cells. These cells dictate the direction and consistency of prevailing winds, which in turn transport different air types and their associated weather conditions. To understand how this impacts a specific region, consider its latitude and proximity to ocean currents. For instance, areas consistently receiving trade winds, which are part of the Hadley cell, often experience warm temperatures and can be either very wet if originating over warm oceans, or very dry if they have already released their moisture or originate over land. Westerlies, found in the mid-latitudes, bring varied weather systems and contribute to the temperate climates of many populated regions. A fascinating insight is the concept of rain-shadow deserts. When moist air from the ocean encounters a mountain range, it is forced upward. As it rises, it cools and condenses, releasing its moisture as precipitation on the windward side of the mountains. By the time the air descends on the leeward side, it is dry and warm, creating arid conditions. This phenomenon dramatically illustrates how prevailing winds, interacting with topography, can carve out distinct climate zones like the Great Basin Desert in North America. Ultimately, recognizing the influence of prevailing winds allows us to appreciate the intricate interconnectedness of our planet's systems. By understanding how these constant air currents transport energy and water, you can better predict and explain the characteristic climates of different geographical regions, from the polar ice caps to the equatorial rainforests, helping you to interpret the global tapestry of our diverse environments.